Hey, Professor,
Yes, sir.
what do them things mean that you showed us before?
I'm sorry.
What does that mean? The slide before about the thing you just
Oh,
explained?
that's just these are fractals. They're composed of, hold on. These are my own art project, okay? Let me in fact get you this. Let's see if we can find it. Oops, wrong one. Sorry. Wrong one. Here we go. A fractal. These are pictures which consist of copies of itself. You can see that this whole labyrinth consists of one, two, three small copies of itself, which themselves are composed of smaller copies, and so on down to this diagonal line at infinity. Well, or at approximately infinity. Now, people say I made these by, they say they look like they were made by computer. Actually, no, I made them by Xerox machine, scissors, paper, and tape. I would make a crude copy, shrink it down to three cases, tape those three smaller copies inside the big one, Xerox that, shrink those down, and so on until it converges to a limit. I make them because I think they're kind of cool. Now, here's a small question for you. The ratio of this big labyrinth to these small labyrinths is the same as the ratio of this smaller labyrinth to the even smaller labyrinth. So what is the ratio? I'll leave that as an exercise. All right, let's proceed.
That's
Yeah,
nice. That's nice.
I have literally hundreds of them by now. Let's see. Let me find one of my favorites. This one's kind of nice. Heart of Gold. In terms of this is the big one is to the middle one, and the middle one is to the small one, in a ratio called the golden mean. But that's for later. Let's proceed.
It's like an illusion,
A what?
an illusion, a tunnel.
Yeah. Well, yeah, I would make these and I would sit in front of them and sort of be hypnotized, zooming down and zooming out, whatever. Anyhow, digression complete. Let's proceed. Where was I? All right. Slope. Slope is a measure of the steepness of a line. So if you have a line and there's this horizontal run and a vertical rise, the slope is the ratio of rise to run. Now, if the line is straight, no matter how far or you extend this, then that ratio is the same because of the straightness of the line. Now, if the line is horizontal, then the slope is 0. If it's vertical, then rise over run is non-zero over 0, which is infinity. Here, the diagonal, 45-degree diagonal for every unit over goes up a unit, so the ratio is 1. Here's a ratio slope of 2. Here's a slope of 1/2. Here, it's going down, so every unit over it goes down 1/2, slope of a negative 1/2. For this line here, for every unit across, it goes down 1, so a slope of -1. This is a slope of -2. This figure I call the slope wheel. So it measures the steepness of the line. All right, given 2 points in the coordinate plane. Here's x1 by y1, here's x2 by y2. The slope of this line, well, let's see. This vertical rise is a change in y2 minus y1. It's denoted delta y. That delta is the Greek capital letter D for difference. From here to here, the run is a change in x, x2 minus x1. And the change in x, that's delta x, the change in x. The slope is the change in y over the change in x, delta y over delta x. That's y2 minus y1 over x2 minus x1. You will see this formula later on if and when you get to the calculus. Now actually, here I have the 2's minus the 1's, but if I multiply above and below by -1, you get the same slope, but it reverses the subtractions. So this will be y1 minus y2 over x1 minus x2. The same slope from here to here is the same as the slope from here to here. So it doesn't matter which order you choose, as long as you're consistent in which order you choose to define the slope. If you have a horizontal line, well, I mentioned that the slope is 0, because no matter how far you run, neither rise nor fall. A line y equals 0, that's horizontal, that's a slope of 0. Y equals 1 is a slope of 0. Y equals -1 line is a slope of 0. Y equals constant gives you a horizontal line with slope 0. X equals constant, like these are vertical lines. And here, the run is 0 for a non-zero rise, so the ratio is infinity. Vertical lines have slope infinity, horizontal lines have slope 0. Vertical is, of course, gives a problem because infinity is a problem to work with. And the book actually is afraid of it. I'm less afraid of it, but whatever. Parallel and perpendicular lines. Oh, did they have to call just now? Excuse me. There. Maybe I should move the phone out. No, I can't. Never mind. Two parallel lines, slope S1 and slope S2. If they're parallel, then the slopes are equal. In fact, it turns out that this equal sign was invented precisely because the guy who invented the sign said that these two little lines are equal to each other, whatever. So parallel lines have equal slope. Perpendicular lines is a little more complicated. Slope S1 and S2. If they're perpendicular, then their product is -1, which means that S1 is -1 over S2, and S2 is -1 over S1. They're negative reciprocal slopes if they're perpendicular. Now here's an explanation as to why negative reciprocal slope for perpendicular lines. Here are two perpendicular lines. Let's have them centered on 0, 0. This one has slope S1. So if you go over a distance 1, it goes up a distance S1. So this point is at 1 by S1. Now if you turn the whole thing 90 degrees, and this point 1, 0 goes to 0 by 1, and this distance S1 goes backwards negative S1. So this point here is at negative S1 by 1. Now this slope between here and here is be slope S2. So S2 will be change in y, 1 minus 0, over change in x, minus S1 minus 0. 1 minus 0 over minus S1 minus 0, that's 1 over negative S1, which is -1 over S1, negative reciprocals. Therefore, their product is negative S1, therefore S1 is -1 over S2. Negative reciprocal slopes, mutually, their product is -1. All right, here's some examples. Here's a line, the horizontal line going through 0 by 4. What's its slope? 0. Here's a line going from -1 by 3 and 4 by 2. What's its slope? Well, the slope is change in the y's. Let's have it 3 minus 2, or change in x, -1 minus 4. That'd be 1 over -5, or more conventionally, -1 over 5. I think it's a good idea in general to have a to write a fraction with a negative sign in the numerator rather than the denominator. And please never put the negative sign right in front of the divide sign, because people have a tendency to jam, if they're in a rush, those two jam together and you're off by a sign. Try to avoid this. Frankly, most of my students' errors are clerical, typographical. Here's asked for the slope between -2 by -2 and -12 by -8. Well, okay, it's the change in y with the change in x. Change in y is -2 minus -8 over change in x, -2 minus -12. -2 minus -8 is -2 plus 8. -2 minus -12 is -2 plus 12. This works out to 6/10 or 3/5. A slope of 3/5. Here's a slope between 5 by 7 and -4 by 7. All right, you can tell since it's the same value of y, it's a constant y, so it should come as no surprise that the slope is 0. Slope is change in y, 7 minus 7, over change in x, 5 minus negative 4. That's 0 over 9, which is 0. Horizontal line, 0 slope. Here's a slope between 8 by negative 4 and 8 by negative 3. Change in y is negative 4 minus negative 3. Change in x is 8 minus 8. Negative 1 over 0, that's infinity. An infinite slope for a vertical line. Because it's a constant x, therefore a vertical line, therefore infinite slope. Slope between negative 3/4 by 2/3 and 4/3 by negative 1/6. Okay, you wind up with some gnarly fraction arithmetic. Change in y is 2/3 minus negative 1/6. Change in x is negative 3/4 minus 4/3. And skipping a few steps, I find it a good idea to skip steps for your sake. This numerator is 5/6, the denominator is 25/12, and then after a bit of fraction arithmetic, you get 2/5. Oops, did I? Oh, I forgot to. Sorry. Here we have two lines, and I'd ask, are they parallel, perpendicular, or neither? One line is from 5 by 3 to 1 by 4. The other line is through negative 3 by negative 4 to 1 by negative 5. First slope, change in y is 3 minus 4, like here. Change in x is 5 minus 1. 3 minus 4 over 5 minus 1 is negative 1/4. The second pair of points, change in y is negative 4 minus negative 5, here. Change in x is negative 3 minus 1, here. That's 1 over negative 4, negative 1/4. These are equal slopes, therefore, those are parallel lines. Here's the same question for the line through negative 4 by negative 2 to 2 by negative 3, and the line through 7 by 1 to 8 by 7. First line is a slope of change in y, negative 2 minus negative 3, right there, over change in x, negative 4 minus 2. This is a slope, and it works out to 1 over negative 6, or negative 1/6. Here, the line through 7 by 1 to 8 by 7, the change in y is 1 minus 7. Here. Over the change in x is 7 minus 8. Here, that's negative 6 over negative 1 is positive 6. So the slopes are negative 1/6 and positive 6. These are negative reciprocal to each other, and therefore these are perpendicular lines. Somebody's got some static on the line. Same question, parallel, perpendicular, or neither for these two lines. 1 through 2 by 2 to 4 by negative 3, then through negative 3 by 4 to negative 1 by 9. For a slope, change in y is 2 minus negative 3. Change in x is 2 minus 4. So this is a slope, comes up to 5 over negative 2, or negative 2.5. Slope 2, change in y is 4 minus 9, here. Change in x is negative 3 minus negative 1, that's here. That comes out to negative 5 over negative 2, or positive 2.5. Now these are not equal, negative 2.5 and positive 2.5. They're not equal, they're not reciprocal, they're negatives. What that means is where basically, if this is going, one of the lines is going like this, and the other line is going like this, they're reflected to the y-axis, reflected up or down. But that's not the same as parallel, equal, or negative reciprocal, so therefore they are neither parallel nor perpendicular. So they ask for the slope of a line perpendicular to the line through negative 1 by 7 and 1 by 10. Now, slope between these 2 points, well, change in y is 7 minus 10 here. Change in x is negative 1 minus 1 here. That's negative 3 over 2. That's 3/2. Now, to find the perpendicular slope, take negative 1 over that, negative 1 over 3/2. So you flip the 3/2 upside down to 2/3 and put a negative sign in front and get this, negative 2/3. That's the slope of that perpendicular line. Okay. Time to call the robot.